Our first look at periodic functions deals with Ferris wheels, and we're introduced into the Singapore Flyer, where we have dimensions such as the diameter is 150 meters, the overall height is 165 meters, and the constant rate or speed that this wheel turns is 26 centimeters per second. And the reason why we're told the speed is also to elaborate on the wheel actually does not have to stop whenever it's loading and unloading passengers. So that's a pretty interesting fact about the Singapore Flyer. In terms of circles and periodic functions, there's several things that we can correlate. We can relate the function to some vocabulary with circles. The periodic functions. A periodic function is y equals a times either sine or cosine of b times x minus c. Notice how the b is factored out, plus d. And what we have here is the general form of a sinusoidal function. Now, what I want to make sure you're able to do is identify what a, b, c, and d are in terms of this circular model. Looking at a, b, c, and d, a is the amplitude of the periodic function, but in terms of something circular, we're looking at the radius of that circle is the amplitude. B is 2 pi divided by the period length. The nice thing about the period length is it can be rewritten in terms of the circumference of the circle divided by the speed at which that circle turns. C is the phase shift, and the phase shift, I'm going to suggest instead of doing a function with sine, I'm going to suggest doing cosine. And then C, the phase shift, is the amount of time it takes us to get to the top, to overall height of this circle. And then D is the axis of rotation, or the center of the circle. How high off the ground is that center? That's going to give us D. The radius distance is going to give us A. The rate and the circumference are going to give us B, as long as we incorporate 2 pi in this little formula. And then the phase shift is going to be a little more difficult in terms of making sure we get phase shift. However, it's basically just an understanding of where do you start on this Ferris wheel. If you start at the top when you start the clock, then your C is 0. If you start at the bottom, then your C is going to be half of the circumference, or half of the time it takes you to get all the way around. So looking again at the equation, y equals a times cosine b times x minus c plus d, we can rewrite it in words to help maybe relate the variables that we need to input into the formula a little bit easier for the students. We have here y is equal to the amplitude of times cosine of 2 pi divided by the period length times x minus c plus the axis of rotation. Or if you're given information that involves circles, y is equal to the radius times cosine of 2 pi times the speed divided by the circumference times x minus c plus the center of the circle. This might allow the students here to be able to input some of the information that they're given, as opposed to calculate a whole bunch of different variables and then input it. And it might allow them to then reduce a couple things while it's in the equation. And now you're looking at, did they write the equation correctly? And maybe if they didn't simplify the equation correctly, now you're looking at maybe only taking off partial credit as opposed to all the credit, where here they might make some pretty major mistakes and not show the work. If they don't show the work, there's no choice but to take off the credit. But here, this is the first step in showing the work, and then they can simplify some fractions and then give you a better equation with a couple steps. All right, so with the information that we were given, the diameter is 150 meters, the overall height is 165 meters, and the speed is 26 centimeters per second. The one beginning issue that we're going to have is making sure everything is converted into the proper units. Well, here we have 26 centimeters per second, and then up here we have 150 meters, 165 meters. So in order to make this meters per second, we just have to divide by 100 and put the decimal in front of 0.26. And that gives us 0.26 meters per second, and it gives us our speed. Now we can go ahead and input a couple of these things. We know that the speed is 0.26 We also know that the radius is 75 meters. So I can change here the radius and I can make that 75. Also, if we know that the radius is 75 and the overall height is 165, then that means I can find the center of this by taking 165 minus 75. And that's going to give me 90. So that means now I can change D to 90. And then my circumference is the only thing I need to fix here. But we know that circumference is equal to pi times the diameter. Well, if you keep it in this form, pi times diameter is 150 times pi. Well, I can then change my circumference to 150 times pi, and hopefully I can start to see one of the first changes here in that pi divides out, and now we don't have to even worry about putting pi in our calculator, which I know is a headache for those of us who like to be exact, put the actual pi button in the calculator, versus those who like to approximate 3.14. And so then we can simplify our equation here. 75 times cosine, and then 2 times 0.26 is going to be, what's that, 0.52 divided by 150. X minus c, now c we can talk about here in just a second, plus 90. Okay, now I told you that we can start the clock and say we're at the top. As soon as we get to the very top of this Ferris wheel, we can start the clock, which means c is going to be 0. The one thing about Ferris wheels is that the timing of the Ferris wheel is all predicated upon when you want to start timing and figuring out your height. However, whenever we talk about the tide, high tide occurs at a certain time, low tide occurs at a certain time, we're going to be given the time of the high tide, or we're going to have to actually calculate it. In this case, we can determine that we begin at the top of this Ferris wheel and then rotate. However, if you want to calculate how long it takes to go from the bottom, which is when you get on the Ferris wheel, to the amount of time it takes you to get to the top, then you would have to first calculate one full rotation. That means you have to calculate the period length The period length is the circumference divided by the speed. So that means we have 150 pi divided by 0.26. And this will give you, this period length here will give you very, very close to 30 minutes. And if it takes 30 minutes to go all the way around, then we can start at the bottom, and halfway around is 15 minutes. So 15 would be the phase shift of when we start at the overall height, or when we get to the very, very top. It's going to take us 15 minutes. Now, the difference between this equation and this equation is just that one graph is shifted over. If we were to graph both, it's shifted over half of the period length. However, the amount of time it takes is irrelevant, because it still will give you the time frame necessary to achieve certain heights, even though your beginning point has shifted over. And that's Ferris wheels.